Hey, it's me, Steve. Sorry. It is August 11, 2017. Time is 16:43. It is 78 degrees Fahrenheit out, and this is a Geo-Rant. Last time I talked about sedimentary rocks. Today I'm going to talk about the rate of deposition of sedimentary rocks. Now, this is something people have tried to figure out for a long time, and you can take chemical rocks like rocks that are precipitated from seawater, like certain carbonates and evaporites, and you can actually run experiments in labs to see how fast you can get carbonates to precipitate out of seawater. And you can even do things like oversaturated or undersaturated. And I think, if memory serves, the fastest that carbonates can be deposited out of seawater in an oversaturated warm solution, I want to say is 6 millimeters a year. That's maximum. We don't have those present ocean conditions. Typically it's more like 0.2 millimeters a year. But I'm going to talk more about clastic rocks, you know, your conglomerates, your sandstones, and your shales. All right. So basically, if you have the question, how fast does sedimentary rocks, classic sedimentary rocks deposit? The answer is, it varies. There is no set standard equation. I mean, it seems pretty simple. Like, you know, your rate would be, you know, your amount of what's being deposited divided by how long it takes. But you have different environments. I mean, clastic rocks, they get deposited in you have terrestrial and marine environments, all right? Within terrestrial, you have rivers, you have gravity flows such as mass wasting, lakes and glaciers. Now, rivers typically do not deposit permanently over the long run. Erosion dominates on the surface of the earth, all right? There are exceptions to this, which I'm gonna get into. But, I mean, the short-term rivers can deposit, but if that doesn't get preserved in the geologic record, you know, whatever, I mean, it doesn't really matter. We're looking for sedimentary rates in the geologic record. Well, then you got mass wasting, like gravity flows, all right, which would be landslides. You could get literally dozens of feet in under a minute of deposition. You also have alluvial fans, which are usually in drier environments. You'll get where a slope changes drastically and you get coarser grained sediments piling up. You could get literally dozens of feet of deposition in alluvial fan during a monsoon season or heavy rain season and then get nothing for years. All right, so there's really no consistent depositional rate there. And then you have lakes and glaciers. Things like bogs that show varves in lakes, they will produce consistent layers, or they'll vary slightly. And we can tell the annual variation by the amount of organics separating between summer and winter. So those are pretty easy. We can actually get sedimentary rates in that situation. And glaciers, well, depends on the size of the glacier, what it's moving over, how big it is, how long it's been there. Is it advancing? Is it retreating? You see, this gets a little complicated. This is why we like to rely on igneous intrusions that cross-cut sedimentary rocks, because we can directly date those, and then we can work from there. And then you get marine deposition. Almost all sedimentary rocks that are preserved on this planet are marine in origin. All right. You got deep sea, shallow sea deposits. Deep sea eventually gets, you know, on the ocean floor, eventually gets recycled due to plate tectonics, so we eventually lose that. The shallow seas are your stuff like, you know, you drive around the Midwest, you'll see limestone quarries, stuff like that. That's shallow sea deposits. You got glaciers again, because glaciers will break off, float, and they'll be carrying dirt and stuff, and then they'll just drop their load as they melt. And then you get turbidites, which are a form of gravity flow just under water, and that's a form of mass wasting as well. And you can literally get several feet of sediments within a couple seconds when that happens. But when you get deposits of clastic rocks, there are two main controlling factors, all right, for deposition. One is basin subsidence. Like with the Mid-Continental Rift, we do have river or fluvial deposits preserved. Well, I just said rivers erode. Yeah, but if the basin's subsiding, and you're getting influx of sediments, if the basin subsides, you're going to get, sediments are going to continue. You're going to get an addition of sediment, not a subtraction. And the second major factor is erosion. Well, what does erosion have to do with deposition? Well, a lot of times we can recognize a lot of erosional features in the rock record or unconformities, which I've talked about before. But if they're not sharp necessarily, we may not know. They're just maybe, you get different types of, you can have one of non-deposition where you get say sandstone, or say a sand coming into a shallow sea. You could get a significant amount of sediment and then just stops. The river that was feeding that has changed direction or something like that. And then when it moves back, sedimentation resumes. And those time spans are very hard to pin down. All right, we can observe how it does it in the modern deposits, which is a good way to estimate it. But we also have when you're talking about like carbonates, you also get what's called diastems. You get periods of just no deposition at all, and they'll form hard grounds on them, so we can pick those out pretty easily. And usually if carbonate rocks are being deposited, if there's a flux of clastic sediments like sand or shale, that'll shut that system off for a time being. How long? See, the whole point of this is, there's so many factors in predicting sedimentary rates that unless you have dated controls with undeformed igneous layers, this can get pretty difficult. Fortunately, there are places on the planet we do, like in the Mid-Continent Rift, we have lava flows in the Copper Harbor and even in the Frida. So we can kind of bracket these things. The Huronian supergroup is lava's on the bottom, it's cross-cut by lavas on the top. So we can kind of get a sense. But for actual depositional rates, well, that depends on the environment. So, sorry, that's kind of lengthy. That's my rant. I hope you learned something.